Yeah. Sir, you are muted.
Did I give you homework from HCV, Field and Potential, complete chapter?
Till 64. So you gave till 64.
No, sir, you gave the full chapter.
You gave the full chapter, sir.
Chapter दिया है first chapter of
Yes, sir.
Okay. Did I send you 2 assignments?
Yes, sir. Yes, sir.
Key for the second assignment, did I send you?
Yes, sir.
When is the next doubt lecture?
Sunday.
Okay. Now today we'll have to introduce the second part of electrostatics. Second part of electrostatics. This is the heart and soul of electrostatics. Right? This is the second part of electrostatics, the heart and soul of electrostatics. This is called Gauss law.
Excuse me, sir.
Yeah.
Sir, you had given us a problem in the last lecture where we had to find the value of friction if the sphere with charge is rolling. Could you please discuss that problem?
Ring.
Yes, sir.
Suppose I have positive charge here, uniformly distributed, and negative charge here. You switched on an electric field this way. You switched on an electric field this way. You will have friction in this direction. On this, I will have field into dq. On this, I will have field into dq this way. Positive charge will experience a force in the direction of field. Negative charge will experience a force opposite to the direction of field. So this and this will cancel out each other. Translational dynamic equation is F equal to ma. First equation, are we okay with this?
Yes, sir.
Next is torque equation about the center of mass. Torque will be E into dq. Right? You are taking this as theta, this as d into 2r sine theta. E into dq into 2r sine theta. Torque due to a couple. This will be r sine theta, 2r sine theta. This we will have to integrate from 0 to pi by 2. Minus f into r is equal to I into alpha. Torque about O. Now dq will be lambda r d. dq will be lambda. What is the charge here? Lambda r d. Minus f into r is I into alpha. I will be how much? mr square. Third condition, A is equal to R alpha, condition for rolling. 3 equations and 3 variables. First integrate this. I will clearly have 3 equations and 3 variables, which will not be difficult.
The answer ER square.
Don't know, yaar. I actually did the simplification yesterday in a hurry and I sent you people the answer key. In that second assignment, this question is there. I have a feeling there should be 2 in front of it. Simplify this and tell me what is the answer you people are getting.
I'm getting ER square.
ER square. You are asking calculate that, right?
ER lambda.
ER lambda आ रहा है आपको?
हाँ sir.
Then that's the answer that I sent yesterday. ER lambda, but I thought maybe 2 should be put in front of it, which I was not sure. ER lambda अगर आ रहा है तो ER lambda ही answer.
Yes, sir, ER lambda.
Okay. Can I rub the board? Now, from here we are making a transition into a new thing altogether. First of all, we define a quantity called electric flux, E dot A. This will be called flux, Newton per Coulomb meter square. Newton per Coulomb meter square, electric flux. Suppose I have an area. From today, area is a vector quantity. Area will be perpendicular to a surface outwards. Area will be perpendicular to a surface outwards. One single ring will have 2 areas. One area this way and one area this way. A I cap, A minus I cap. One single sheet. Till now a rectangle had only one area. Right? Now the rectangle will have 2 areas. One in this direction, one in this direction. That means you are referring to this or this. This side is area into this is the vector quantity. This side, this is the vector quantity. From today, area is a vector quantity. Is that point clear?
Yes, sir. Sir, both areas would be same, right?
Magnitude. Directions are different. Magnitude of both areas are the same. Directions are different. So when you define an electric field like this, listen carefully. If you take a rectangular plate like this, flux through this surface will be EA cos Z. Electric flux through the front face will be EA cos 0. Through the back face will be EA cos 9. This side will be EA cos 180. Electric flux through this face will be EA cos 0. Through this face will be EA cos 180. Is that clear? We define a new quantity called electric flux, E dot A. A raw deal to visualize electric flux is a number of electric lines of force intercepting a surface perpendicularly. A very crude way to visualize flux is number of lines of force intercepting an area perpendicular to it. If this is the area, I have say 10 lines intercepting this surface. If I increase the field, flux will increase. If I increase the area, flux will increase. If I turn the area, flux will decrease. Cos 90 is 0. Same thing I will keep this way. Electric lines of force are intercepting, or electric lines of force are like this. What will be the flux through this? E into A into cos 0. Slowly when I turn this particular surface.
So EA cos 180, right?
One second. Slowly when I turn this particular surface. Now see, electric field is this way. Electric field is this way. Right? Is there any line intercepting this surface?
No.
No. So it is 0. And actually 0. What is the area vector?
Cos
Area
90.
like this. Field is this way. Cos 90 is 0. Right? If I keep it this way, EA cos 0. If I keep it this way, EA cos 180. So I didn't change the field, I didn't change the area, but if I change the orientation, flux is changing. Hence, area has been made a vector quantity.
Sir, so we can visualize flux as flow rate, right?
Yeah, flow rate, and these are the crude ways of visualizing flux. Why are you using the crude way? Why not the right way? Because electric field lines are hypothetical. You don't have anything called electric field lines. Imaginary lines. Electric field lines are called imaginary lines.
Done, sir.
Now, one more way of visualizing this If I have an electric field like this is the area vector. This is the area vector. This is theta. I call this PQRS, and this will be LM. Flux through LMRS will be EA cos theta. Say something. LMRS.
Yeah. So that's perpendicular, right?
This phase is the hypotenuse of the inclined plane, and this will be the perpendicular. If you are seeing the two-dimensional view, it will be like this. This face will be perpendicular to the board inwards. All three are perpendicular to the board inwards. Are you able to visualize?
Yes, sir, like a wedge.
Now, I am interested in what? Flux through L, M, R, S. So, E into A into cos theta.
Yes, sir.
Yes, sir.
Now, this is a dot product. Dot product of A dot B. Either you can resolve B along A or A along B. So, this will be E into area of LMRS into cos theta. This could as well be E into area of LMRS into cos theta could as well be area of PQRS. This area vector into cos theta will be PQRS. Are you able to visualize that?
Yes, sir.
That's nothing but you are projecting the area this way. You are projecting the area this way. When area is projected along the field, it should be the area of PQRS. This is the inclined plane. This was the field. This was the area. If I resolve area along the field, it is as good as telling you it is this area. If I resolve
sir.
the area along the field, it is as good as telling you it is this area. Yes or no?
Yes, sir.
Something small and silly, but you'll have to remember. Either you resolve field along area or area along field. They are okay either way when it comes to dot product.
So won't we get different answers then?
The different answers, why will I equate them? A cos theta is along E. A cos theta. This cos theta is which area? If I resolve this area, in this direction, don't you think it will be this particular PQRS?
So cost component should be the base, right?
Pardon?
Cost component should be the base, right?
ढंग से देखो, if this is theta, this is not theta. This will be.
Yes, sir, right.
If this is theta, this will be. Tell me when I conduct the board.
Done, sir.
Now we take this one more step ahead. Something that you people should have learnt in schools, but you didn't. Something very silly. First of all, we are aware of something called sector. star formula, theta and r. Theta is as pi r. Do you agree with that?
Yes.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Take a circle, what is the angle subtended at the center?
2
pi.
2 pi.
2 pi.
2 pi. Take a circle and what will be the angle subtended inside but not at the center?
What, sir?
Angle subtended here,
2 pi.
2 pi. How will you justify that?
So take the point inside the at the center and then just make the angle measure to a
Draw
right.
a circle. Keeping this at the center, draw a circle.
So what connection does it have with the bigger circle?
Can you wait? Right? Now I am interested to know what is the angle subtended here. Keeping this at the center, I drew a circle. Again, can I claim this line and this line subtends the same angle?
Yes, sir.
Can I claim this line and this line subtends the same angle?
So can you repeat that?
Can I claim this line and this line will subtend the same angle at that
Yes,
point?
sir. Yes.
Can I claim this line and this line will subtend the same angle?
Yes, sir.
So both put together for this circle, this will be 2 pi because it is at the center. So angle subtended inside will be 2 pi.
Yes, sir. Understood.
Is the board clearly visible?
Yes, sir.
What are you trying to prove here? Take an arbitrary closed loop. What will be the angle subtended inside?
2 pi.
2 pi. Arbitrary closed loop. Here my video froze here. I don't know if you are able to see.
So we are
clearly.
able to see it's not frozen.
Yes, sir. It's clear.
Now, keeping this at the center, draw a circle. So can I claim this length and this length will subtend the same angle at the center?
Yes, sir.
Similarly, this length and this length will subtend the same angle at the center. Continue doing that way. If I add all the angles, it will be 2 pi.
Yes, sir.
What are you trying to prove here? You are trying to prove that for any closed loop, anywhere inside, angle subtended is 2 pi. You are right. Any closed loop, angle subtended anywhere inside will be 2 pi. What is the big deal in this here? Something very elementary here. Yes. We will tell you what is the big deal. Take it down.
Done, sir.
Now this was a line integral. This was a line integral. What if you take a surface? What will this surface be? This angle will be called solid angle. Theta was L by R. Solid angle will be delta S by R square. Area by R square. Theta was linear angle. Linear angle was length divided by R. Solid angle is area divided by R square.
What is solid angle?
Is area divided by R square. What precisely would be a solid angle here? Do you see the solid angle inside?
Yes, sir.
This is the solid angle. What will be the linear angle? Linear angle will be this. Now this became a line. Now this became a line. Line divided by R square is linear angle. Here, what is the angle? Solid angle. Are you able to see the solid angle inside? This
Yes, sir.
area will subtend a solid angle. This area will subtend a solid angle. Are you able to see this area?
Yes, sir.
Yes,
This
sir.
area is not a line. If I make it this way, this will be a line, this will be linear angle. If I show you this, it is not a line which subtends the angle inside. It is the
Area.
area
by R square.
angle. That angle is called solid angle. रोड साइड बेल कभी खरीदा आपने?
हाँ sir.
Right? This is precisely solid angle. Now,
So why are you dividing it by R square?
not this level dimension. If I put as area, theta is
Right, sir.
I made this area, this will be R square. Now, what if the area is tilted this way? This is delta S. Yet the solid angle will be the same because this is theta. Now, solid angle will be delta S cos theta by R square. Delta S cos theta. Ultimately, I should get this delta S area along this radius. If it is not, resolve the delta S area along the radius. Indirectly, I am telling you this is delta S, this is delta S dash, this is delta S, this is delta S dash. Both subtend the same solid angle. Why? Delta S by R square or delta S dash cos theta by R square will be the same. This is delta S divided by R square. This is delta S dash. Delta S dash you resolve along delta S. It will be delta S dash cos theta by R square will give me the same solid angle. Is this point clear to all?
Yes, sir.
Take it down, we'll build up.
The unit is steradian, right?
steradians, right?
So delta S is area or the difference of the area?
Delta S is the area of this.
Yes, sir.
Technically, because I used delta, you get that out. Is it difference of the area? But bottom line, a small element's area, hence I put it delta S. If you people observe, I'm taking that to be a flat surface. Technically, it will be a curved surface.
Yes,
So a
sir.
small area will appear like a flat surface.
Done, sir.
So
Spherical wave fronts. If the distance of the source is different, then there is increase in radii of the sphere and form as concentric spheres. Let us consider a sphere of radius r. Let us also consider a small area A on the surface of the sphere as shown in the picture with shaded region. Now, let us draw number of lines from the source S. Thus, all the lines meet the boundary of the region A, and thus all lines form a cone. The angle at point S, which is covered by conical surface, called as solid angle, d omega. The solid angle can be measured by the ratio of area A and square of the radius r. The solid angle is measured in steradians. Now, let us learn the definition of solid angle. When the normal lines are drawn from the boundary of a portion on the surface of a sphere, such that lines meet at its center and form a cone, then the angle enclosed by the conical surface is defined as solid angle, and it is equal to the ratio of the area of the base of the conical surface, the portion on the sphere, to the square of the radius of the sphere. Thus, the solid angle made at S by an area A is d omega. Therefore, d omega is equal to A by r square. Let us assume area A is equal to 1 unit. Radius r is equal to 1 unit. Thus, d omega is equal to 1 steradian. As we already know, area of the sphere is A is equal to 4 pi r square, as the radius is r. Therefore, total solid angle for the sphere as a whole is d omega is equal to 4 pi r square by r square. Therefore, d omega is equal to 4 pi steradian.
So 4 pi was for the entire sphere, right?
Right. Now, you are able to visualize the solid angle now?
Yes, sir.
Now we take this one more step ahead. Suppose I consider a spherical surface at the center. Solid angle is A divided by R square or delta square R square. What is the area? 4 pi R square R square. Don't tell me I got 4 pi R square from this. You know how we derived 4 pi R square? By taking a ring. By taking a ring.
Yes, sir.
What is the surface area? This is theta, this is d theta. This is r d theta. What is the surface area of the ring? dA is 2 pi r sine theta. Radius of the ring is r sine theta into r d theta. You integrated this 2 pi r square integral sine theta d theta. Least value of theta is 0, maximum value of theta is pi. 2 pi r square integral sine theta is minus cos theta. Cos pi minus cos 0. 4 pi r square. Here we did not use the concept of solid angle anywhere. So 4 pi r square you substitute here, you will get the solid angle subtended inside a solid sphere is 4 pi. Right? Can I go one more step ahead and ask you what will be the solid angle subtended here?
4 pi square.
4 pi. Solid angle subtended anywhere inside. How will you visualize that? Consider a sphere with this at the center. This surface will subtend the same solid angle. This surface and this surface will subtend the same solid angle. For this sphere, if it is 4 pi, for this sphere also it will be 4 pi. Are you trying to tell me anywhere inside the closed sphere solid angle subtended is 4 pi? Yes or no?
Yes, sir.
Convince it till here.
Yes, sir.
Take it down till here.
Sir, so the same statement we wrote for 2 pi will be applicable here also.
For 4 pi.
Sir, shouldn't solid angle be unitless? Because area upon radius square, the units will get
Doesn't have
cancelled.
dimension. Doesn't have dimension, but it's a physical quantity.
Yes, sir.
The angle will not have a dimension.
And so when will you do the units and dimensions remaining part?
In fact, while dealing with this, I was reminded of it. I was about to tell you people of that. Electrostatics first will finish units and dimensions.
Because we have started and one lecture we did, then we left.
Yeah, because now that you know quite a few physical quantities, viscosity, electric field, all this you people know, now we can finish units and dimensions.
Sir, units and dimension is done in Andheri.
No, sir.
No, sir, it's not done.
Yes, sir, it's
It's
done.
not done.
ओके अगर हो भी गया रिवीजन हो जाएगा बहुत ही छोटी सी चैप्टर है मगर हर साल एक क्वेश्चन आता है उससे राइट टू बी ऑन द सेफ साइड एक बार कर लो बहुत सिली चैप्टर है बट इंपॉर्टेंट initial stages for us to teach the chapter is very difficult We don't know time constant, we don't know capacitance, we don't know electric field, magnetic field. Epsilon naught का dimension पूछते हैं, epsilon naught है क्या भी पता नहीं बच्चे को.
So I think a first question है.
Yeah, so we have to wait for the general. Now we can.
सर यही एडवांस में पूछ रहे हैं.
JEE एडवांस में भी पूछते हैं, मेंस में भी पूछते हैं. मेंस में तो हर साल एक क्वेश्चन गारंटी है. और बड़ा आसान होता है. ऐसा मैंने कभी नहीं सुना कि कोई बच्चा आकर बोले सर यूनिट्स एंड डायमेंशन का क्वेश्चन गलत है. यू विल ऑलवेज स्कोर इन द चैप्टर. Can I rub the board?
Yes, sir.
No, listen. Any closed surface anywhere inside the solid angle subtended should be 4 pi. Any closed surface anywhere inside the solid angle subtended is 4 pi. Any closed surface solid angle subtended anywhere inside is 4 pi. क्यों कर रहे हो यार ये सब? थोड़ा सिली लग रहा है हमें. All of a sudden there be a sudden transition to a huge concept. Concentrate on this. First write this down. I need the whole.
Sir, so like you're saying for any 3D object, the angle subtended will be 4 pi.
Any what object?
3D object. 3-dimensional.
Any 3 dimension. If it is a closed surface, take a cube. Cube has sharp edges, no yaar. We don't care. Take a cube. Anywhere inside the solid angle subtended inside is 4 pi. If it is a closed surface. Why any closed volume? Somebody is typing, should we call it closed volume? Take area. I should have an area subtending an angle inside, not volume. I showed you the video, right? Are you able to visualize solid angle after seeing the video?
Yes, sir. So it will be valid for even for a hollow sphere or right?
Hollow ही लेंगे हम. Solid ले लेंगे तो अंदर solid angle. मगर solid के लिए applicable is the same. But अगर solid sphere ले लिया, you are taking the surface area, subtending an angle inside. Solid angle is always area by r square. Volume नहीं है.
So if you take hollow, then in some it will have area only on the surface, right? Not inside.
Area ही लेना है हमें. Hollow solid का confusion is altogether an unnecessary confusion. Cube लिया है, area लिया है, volume से क्या लेना देना है मुझे? Now listen. The solid angle subtended is omega at this point. I have a charge Q here. area, I'll call it A1. Can you make a guess as to what will be the flux through this area if this distance is R? E1 dot A1 will be the flux through this area. Yes or no?
Yes, sir.
E1 is directly proportional to 1 by R1 square, rather inversely proportional to R1 square. So, by sir, inverse square law KQ by R square. Area के लिए solid angle is A1 by, I'll call it R1 square. Area is directly proportional to R1 square if the solid angle is the same. Say something.
Sir, so you are saying that solid angle can be same for two different areas?
Yes, if the solid angle is the same, a constant, area will be directly proportional to R1 square.
Yes, sir.
That means if two surfaces subtend the same solid angle, flux will be the same. Two surfaces can subtend the same solid angle. Observe this. If I take another surface like this is A2 and this is R2. Don't you think A2 is subtending the same solid angle here? Solid angle is A2 by R2 square. As I am going from here till here, area will be 4 pi R2 square for a closed sphere. 4 pi R2 square by R2 square. Here 4 pi R1 square by R1 square for a closed. Here, as the area is increasing, radius is also increasing. Area increases proportional to R square. Radius R square. So these both surfaces will subtend the same solid angle here.
नहीं सर, ये नहीं समझा.
1 second, wait. Bolo, right. Firstly, I repeat, this area and this area will subtend the same solid. Quite obviously, you take an L here. This L1 and this L2, don't you think will subtend the same linear angle theta?
Yes,
Yes
sir.
or no?
Yes, sir.
Yes, sir.
Now this area and this area will subtend the same solid angle here. Do you agree with that?
Yes, sir.
So
Yes.
how are you saying that? Because A2 by R should be.
And this length, will it subtend the same angle here?
Yes, sir.
So why are you asking me how is it? पर अभी तक वही तो comparison सिखाया मैंने. This circle and this circle, will they subtend the same angle inside?
Yes, sir.
So here, if this length and this length can subtend the same linear angle, this area, when they subtend, don't you think they will subtend the same solid angle?
Yes, sir.
Right? Now listen, most important, when I calculate flux through this, it will be E1 dot A1. When I calculate flux through this, it will be E2 dot A2. E is inversely proportional to R square. Area is directly proportional to R square. Product, will it become dependent on solid angle?
Yes, sir.
Yes, sir.
So we are trying to tell you, if two areas subtend the same solid angle, the flux through both of them will be the same. If two areas subtend the same solid angle, flux through both will be the same. Why? Field is inversely proportional to r square, area directly proportional to r square. So if two areas subtend the same solid angle, flux through both of them will be the same. Till here is it clear to all?
Yes, sir.
Yes, sir. So flux will be same throughout the entire surface.
Now what Gauss said is, if I take a closed surface, you take any closed surface, angle inside will be 4 pi.
Yes, sir.
When you are telling me two areas subtend the same solid angle, they will have the same flux. Closed area always subtends the same solid angle. And flux through all closed surfaces should be the
Same.
Same.
This is the origin of Gauss law. If you are telling me two areas with the same solid angle will have the same flux, closed surfaces all throughout have the same solid angle of 4 pi. So any closed surface flux will be the same. Yes, it will be the same. That is where Gauss law starts. Take it down till here.
Sir, here if at the end, if you draw a semicircle, like a big
Come
one,
again. Come again.
at the right hand end of the shape, if you draw a big semicircle, so like to close the object, the walls of the container. Yes, sir, like that.
Okay.
So, sir, any small area on that, will it also subtend the same angle?
When you take this area, it will not subtend the same angle. 1 second. Let's go. वहां पर
पानी आ रहा है
पानी नहीं
हाँ पानी में कपड़े निकल गए कलर तो उसको कलर निकाल के कुत्ते
देख लो
पानी बाहर से पानी
एक सेकंड
पानी पे भेजे
So you're still muted.
Sir, you're muted.
So you're muted.
Yeah, sorry. Now listen. If I take one small area of that area, then that area will subtend a different solid angle. Are you able to see this solid angle?
Yes, sir.
This complete area will subtend a solid angle. If you take one part of it, the solid angle subtended will be different.
So actually, I was not talking about that area. Like if you just close this cone like an ice cream, yes, sir, like a big semi-hemisphere on the top.
Right? It will subtend the same solid angle here. How many surfaces you draw, what matters for me? Draw another surface here. Till when you are in the same between the two lines, solid angle subtended will be the same.
So I'm not talking like that. So you just close that two lines with like a end with a spherical shape. No, sir, not like that.
You want to take a shape like this?
Yes, sir. At the
That
end.
was not for me. Immaterial, most trivial thing. You want to take the curved shape this way?
Yes, sir.
That
That's
was
what.
not for me. Solid angle is the same. Actually, all these are curved surface. You are concentrating on the most unnecessary parameter here. You are taking straight surfaces because you are taking small surface. None of these surfaces are straight. All of them are curved.
Okay, sir.
All of them are curved. Then why are you drawing straight surfaces here? Because they are small enough. Right? Why are you
Yes, sir.
showing curved surfaces? Because you are taking small areas. To do a big diagram for proper visibility.
Excuse me, sir.
Ah,
So does this mean that a sphere of radius 1 meter and of radius 1 kilometer will have the same flux through them?
that's
Because
what we
the
are going to prove. That's what we are going to prove. If two areas, try to concentrate on the main concept. Two areas subtend the same solid angle here. Flux through both of them will be the same. Why? Flux is E dot A. Field will decrease at a ratio of 1 by r square. It will increase. Area will increase at a rate of r square. Product will be the same. You take an area here. You take an area here. You take an area here. You take an area between these two. All subtend the same solid angle. Flux through both of them will be.
same.
This point is important. Get that very clear. So Gauss said, till when solid angle subtended is the same, then consider a closed surface. Any closed surface will have the same solid angle inside. So flux through any closed surface should be the same. Yes, it will be the same. Is this point very clear?
Yes, sir.
Yes.
Now, will you calculate that flux? Obviously, yes. Tell me when I can rub the board.
Done, sir.
So, what is our contest? The contest is, Parth, don't send me messages now. Something important is being taught. Please concentrate on it. Right? Don't get diverted. What I'm trying to show you, you have to see. Whole of electrostatics is based on. You are trying to search something which is totally unnecessary for this. Now listen. I repeat one point here. All these are curved surfaces. Why did you draw plane surfaces? You are taking very small area. I showed you the video for that sake. What did you people see in the video? I don't understand. You take a sphere, you take a small area. Will that area be almost a plane surface?
Yes, sir.
Those areas that we have taken, right? Now, what is the key catch in our concept? These areas, if they subtend the same solid angle here, they will have the same flux. Listen carefully. Now here I am able to justify. What are you justifying? Increase in area by r square, decrease in field by r square. So the product gives me constant. Field decreases at the rate of r square. Area increases at the rate of r square. So the flux will be constant. This is what you are telling me?
Yes, sir.
Now, a genuine doubt that will come to the student's mind is, they'll say, okay, you are telling me here area increase, field decrease, product is the same. What if area increases but field doesn't change? ये कैसा हो सकता है यार? Have a look. The student says, I am taking this area. Area तो बढ़ गया. You have increased the area. Let me call this A2. Right? But field here did not change. It is dependent on R1 only. When you went out, area increased, field decreased. Field did not decrease, but area increased. But don't you think this area also subtends the same solid angle?
Yes, sir.
So flux should be the same. How is that possible? E1 dot A1 you claim will be equal to E1 dot A2 because both are subtending the same solid angle. Yes, they will be. Yes, they will be. Why? E1 A1 cos 0. This is E1 A2 cos theta. Can I claim A2 cos theta to be A1?
Yes, sir.
So even when I tilt the area, if the solid angle subtended is the same, flux will be the same. Even when I tilt the area, if the solid angle subtended is the same, flux will be the same.
Yes.
And Gauss said, for any closed surface, solid angle subtended anywhere inside is the same. So flux through any closed surface should be the same. Yes. We will prove and calculate that particular area. Take it down to you. Can I rub the board?
Yes, sir.
Now listen to what Gauss did. He says, if two surfaces subtend the same solid angle, flux through both of them are the same. So any closed surface you take will subtend the same solid angle. Take a surface like this. I have a charge Q here. What is the solid angle subtended by this surface on this?
4 pi.
2 by
4 pi.
4 by 4.
So flux through this and this will be the same.
Yes, sir.
Yes, sir.
S1, S2, S3. Flux through S1 is equal to flux through S2 is equal to flux through S3 because all three surfaces subtend the same solid angle on Q.
Yes, sir.
How much is that flux is what Gauss calculated, and that is Gauss law. First of all, before I calculate the flux, turn the pages of your notes, go through what we have covered till now. Tell me if you have a doubt, then we will go.
So solid angle is same for all three because the linear angle is also same, right?
Linear angle, solid angle visualize करने के लिए दिखाया आपको. Linear angle has got nothing to do with solid angle relation. All three are closed surfaces. We gave the justification that for any closed surface anywhere inside, angle subtended is
4 by.
4 pi. So for a surface, how will you define linear angle? We cannot.
Okay, sir.
For a surface, we will define solid angle only. Till here, is it clear to all?
Yes, sir.
Then take this down. We will calculate what is the flux through any closed surface.
Sir, it is clear, but it is seeming a little counterintuitive.
Come again.
Sir, it is clear, but it's seeming little counterintuitive. Does not like, how can flux through weird surfaces be same? I'm getting confused, sir.
You'll have to tell me your doubt. Confused means at which point should I address? It is counterintuitive. You have no choice. From here, the subject itself is in non-intuitive physics. Electromagnetic wave, how do you want me to visualize? Means we will not be able. Right. Point to be understood. If you have got two angles, these two areas will subtend the same solid angle. E dot A. Field is inversely proportional to R square. Area directly proportional to R square. The product will be the same. So two areas with the same solid angle will have the same flux through both of them.
Yes, sir, clear.
Can I rub the board?
Yes, sir.
Yes, sir.
Now Gauss calculated this flux and that became Gauss.
Also, we could calculate for a simpler object, right? Simpler. We can calculate for simpler closed surface and it will be same for all.
It will be same for all. Any closed surface, the flux will be the same. First Maxwellian relation is Gauss. He took an arbitrary surface like this. There is a charge Q enclosed inside. He considered this area, he called it ds. This area, this is a closed surface, not a line integral. This is a closed surface, not a line integral. Right? Field because of this will be like this. This is theta. So far, so good. Yes or no? What will be the flux through this area? Tell me.
E dot ds.
E dot ds. I take this distance to be r. E will be 1 by 4 pi epsilon naught q by r square. ds cos theta. So far, so good. Yes or no?
Yes, sir.
Q by 4 pi epsilon naught ds cos theta by r square will be d phi. इस सर्किल ऑल ऑफ सडन कहां से लिया यार आपने? क्लोज्ड सरफेस इंटीग्रल. Closed surface integral. This surface is closed. Can you recognize ds cos theta by r square as d omega, the solid angle subtended here?
Yes, sir.
ds cos theta divided by r square will be the solid angle subtended here. ds cos theta by r square is the solid angle subtended here. For a closed surface, integral d omega will be how much? For a closed
4 pi.
surface,
4.
integral d omega will be how
4 pi.
much?
4 pi.
4 pi. This is q by 4 pi epsilon naught into 4 pi. Flux is closed integral E dot ds is q by epsilon naught. E dot ds is q by epsilon naught. Q is the charge enclosed inside the Gaussian surface. Charge enclosed inside the Gaussian surface. You used a new word called Gaussian surface. This surface is called Gaussian surface. Charge enclosed inside the Gaussian surface. Whatever is the charge enclosed inside, by epsilon naught is the flux through that surface. Listen carefully. Q1, Q2, right? What will be the flux through S1?
Q1 by epsilon naught.
What will be the flux through S2?
Q1 plus
Q1 plus
Q2.
Q2.
Right? Flux through S1 is Q1 by epsilon naught. Flux through S2 is Q1 plus Q2 by epsilon naught. You mean to say charge enclosed inside the Gaussian surface is only to be taken here? Yes. The flux through any closed surface will be Q net enclosed by epsilon naught. Net enclosed by epsilon naught. If the charge is outside the Gaussian surface, flux through the surface due to the charge will be zero. Q1, Q2 will not produce any flux through this surface. Q2 will not produce any flux through this surface. We will prove that temporarily, that is given as an information. Take it down till here.
Sir, I have a doubt.
Hmm.
Sir, this surface S2 will have some flux and the surface S1 will have some other flux.
Right.
So of the surface of S2 that is enclosed within S1, that part.
S2.
There's a part of S2 that's in S1 as well, right? According
Right.
to the. So
Right.
what was the flux there, sir?
How do I tell you arbitrary functions? What is the flux? You are asking me what is the flux through this surface?
Yes, sir.
Surface integrals.
Okay, we'll calculate it otherwise. Okay.
So won't one charge create an obstruction on the flux of the other charge?
Field is superimpositive in the sense field justification. How do you give? One charge will not produce any, or I'll put it this way. Why unnecessarily that? Keep that in a range, you'll understand that by default. In fact, I should define what is the field. Field is because of all the charges. It is V1 plus E2 plus E3. But if I tell you that, you will get confused now. Wait a minute. That will come in the next class.
Sir, can you please explain the S1 S2 part once again?
1 second, wait. Bolu, tell me your doubt.
Sir, can you explain the left-hand side example once again?
S1 is a surface which is enclosing Q1. Right? So flux through S1 will be Q1 by epsilon naught. Flux through S2 will be Q1 plus Q2 by epsilon naught. Q is the net charge enclosed inside the surface. I'll take one more example if you can give me this part of the board.
Okay, sir, I understood the part. Thank you.
Can I rub this part of the board?
Yes, sir. So you told that you'll convert a regular lecture into a doubt lecture this week.
One we have done here, day before yesterday's lecture, doubt lecture ही किया था. We didn't deal with electrostatics.
Oh, yes, sir, sorry.
No. Have a look at this. Q1 minus Q2, Q3, and you have a Gaussian surface like this, Q4. Gaussian surface. What will be the flux through this closed Gaussian surface? Could you tell me how much will be the flux?
Q1 minus Q2 plus Q3 by E naught.
Repeat 5 times. It is not E naught, it is epsilon naught.
Epsilon naught. Epsilon naught. Epsilon naught. Epsilon naught. Epsilon naught.
Epsilon naught. This step, is it clear to all?
Yes, sir.
Yes, sir.
All of you?
Yes, sir.
Yes, sir.
All of you?
Yes, sir.
Yes, sir.
Now the most dicey thing. Keep this as information. I will justify this in the next class. The field is due to
Charge
All
Q1
Q2,
minus
Q3,
Q2
Q3 and Q4.
and Q4. क्या बोल रहे हो यार? Q4 तो आपने इक्वेशन में लिया ही नहीं. But you are telling me field will be because of all the charges within the vicinity. Yes. That's the beauty in Gauss law. Right hand side Q net enclosed will be the charges enclosed inside the Gaussian surface. But field will be because of all the charges within the vicinity.
So
Can
field,
you give me a justification for this? Will be given, and if Q4 produces field, it should even produce flux. No यार, Q4 के वजह से आप बोल रहे हो यहाँ field भी होगा, मगर flux 0 बोल रहे हो. Can you justify this? We will justify this. But right now, remember this as information. If this is a Gaussian surface, then right hand side charge will be only the charges inside the Gaussian surface. But field will be because of all the charges within the vicinity. Field is due to all charges within the vicinity. This is highly non-intuitive. If I have taken Q1, it is more like telling you there are 5 forces acting on me. I will find acceleration only because of 5 forces. 6th force is not acting on me, but you want me to take acceleration because of that? Here, yes. It is highly non-intuitive, but will be justified. Right? Remember this, it's important. These charges are the charges enclosed inside the Gaussian surface only. Field is because of all the charges within the vicinity.
so you're saying field due to Q4 dot ds is 0.
E dot ds due to Q4 will be 0. E dot ds due to Q4 will be 0. Q4 will not produce any flux through this surface, but will generate a field. Q4 will not produce any flux through this surface, but will produce a field. And you will be 100% convinced with that in the next class.
So you are saying even if we bring 100 charges out of this surface, we will only have flux due to the 3 charges inside, right?
Flux through a closed surface is only because of charges inside the surface. Flux through a closed surface is closed. Word is important, closed. If I keep a surface open, nothing of this theory will be applicable. Why? Only for a closed surface, angle subtended inside is 4 pi. The moment it is not a closed surface, I think a million times before applying this one. For any closed surface, flux will be only because of charges inside the surface. Now somebody typed, can we do the same thing for gravitation? Yes, we will. Then why didn't you deal with this in gravitation? Because Gauss law is not defined for gravitation. We can extrapolate it, converting 1 by 4 pi epsilon naught into gravitation, charges into masses, right? We can do it. But Gauss law didn't define that way. Hence, we didn't define Gauss law in gravitation. All the derivations that you dealt with in gravitation using calculus, 2 steps we will do it using Gauss in electrostatics. It has got its own dynamics. Don't jump to any conclusions with what I have covered till now. There is one complete lecture of interpretation of only this equation. It may sound funny, but there are many intricacies which we are supposed to address. So don't jump to conclusions before the next class. Wait till the next class. Can I rub the board?
Done, sir. Yes, sir.
When is the next class?
Sunday.
Doubt lecture.
Sunday
sir.
doubt lecture है यार.
So
Next will probably be 26th.
next week then.
Listen,
Today,
1 second, listen to me. Can we convert, this topic is half done. Can we convert Sunday's lecture into a doubt lecture and that next Sunday's doubt lecture into a regular lecture and that next lecture is a doubt lecture?
Yes, sir.
Yes, sir.
Yes, sir.
Because this need to be continued. This job is not yet done. It is half done. So Sunday's lecture will be a regular lecture. The immediate next lecture will be a doubt lecture. Is that okay with all?
Yes, sir.
Yes, sir.
Please
Yes, sir.
attend Sunday's lecture. Under the impression it's a doubt lecture, you miss on it. It will be the most biggest mistake you commit as far as electrostatics is concerned. Sunday's lecture is mandatory. Clear with all of you?
Yes, sir.
Please remind your classmates Saturday evening that Sunday's lecture is mandatory. Very important part of electrostatics will be dealt.
Okay, sir.
See you people on Sunday. Don't forget to attend that lecture. Assuming it's a doubt lecture, you miss on it, you will be missing on something very important.
Thank you, sir.
thank you, sir.